Today we're going to solve quadratic equations that will come out having complex roots. Complex numbers, remember, are numbers in the form of a plus bi. In other words, they have a real part. The real part is the a part of this, and the bi is the imaginary part. And when you have a real plus an imaginary part, you have a complex number. And when you have a quadratic equation, when the discriminant is negative, you're going to have complex roots. So we'll just add that note. Complex roots means your b squared minus 4ac, which is the discriminant, will be negative. Right? That's imaginary roots or complex roots. So the b squared minus 4ac is important. So we have x squared minus 4x plus 9, and I want you to solve it in two different ways. We'll get the same answer, but two different ways. The first way is using the quadratic formula. The second way is using complete the square. But when all is said and done in the very end, we should get the same answer. So the quadratic formula requires us to do a is 1, b is negative 4, c is positive 9. So the quadratic formula goes x equals opposite b plus or minus square root b squared minus 4ac all over 2a. All right, that's the quadratic formula. Now we have 16 minus 36. 4 plus or minus the square root of 16 minus 4 times 9 is 36, all over 2. 16 minus 36 is negative 20. So 4 plus or minus the square root of negative 20, all over 2. Well, when you have a negative underneath the square root, you're going to pull it out and call it I. 4 plus or minus I. And the square root of 20 will break up into 4 times 5. And the square root of 4 is 2. So we'll have x being equal to 4 plus or minus 2i square root of 5 all over 2. And now what we're going to do is we're going to split this apart into the a and then the bi part. So we have 4 over 2 plus or minus 2i square root of 5 all over 2. Well, they reduce down. 4 over 2 is 2, plus or minus, those 2's will cancel because they're factors, I square root of 5. So 2 plus or minus I square root of 5 would be the answer if you use the quadratic formula. Complete the square, you'll see, is a lot faster. Complete the square says x squared minus 4x plus 9 equals 0. The first step on completing the square is subtracting 9 from each side. So we're left with x squared minus 4x, and then remember plus blank is equal to 0 minus 9 is negative 9 plus blank. What goes in the blank? Half of b squared. Well, half of negative 4 is negative 2. Squared is 4. Don't forget to square it. Half of b squared. This factors into x minus 2 times x minus 2. Negative 9 plus 4 is negative 5. Taking the square root of both sides, plus or minus, we get x minus 2 is equal to plus or minus, well, this negative is going to come out of the radical and be called I square root of 5. And then, to solve for x, you're going to add 2 to both sides. So you get x is equal to 2 plus or minus I square root of 5. This method is a lot faster than using the quadratic formula, and you didn't even have to reduce it in the end. So either way, you're going to get the same answer. But if you have a b value that's even, it's a lot faster to use complete the square than going through the whole quadratic formula. This is a lot easier. So the answer would be 2 plus or minus I square root of 5, which is option 1. Question number 2. When you see a plus bi form, when you see that, that's like a key word saying you're going to have a b squared minus 4ac will be negative, which means you either are going to use the quadratic formula or complete the square. Now in this particular example, because we have a 3 here, I would probably use the quadratic formula on this one. It might be a little bit easier than, because we're going to have to deal with fractions to do the complete the square. So x equals opposite b plus or minus the square root of b squared minus 4 times 3 times 4. Well, 4 times 3 times 4 is 12 times 4, which is 48, all over 2 times 3, which is 6. 6 plus or minus 36 minus 48 is negative 12. And negative 12, remember, we're going to bring that negative outside and call it I. So 6 plus or minus I. And then the 12 breaks up into 4 times 3. So the square root of 4 is going to be pulled out, and we're going to call it 2i squared of 3. And now we're going to break it up into the two parts, which is 6 over 6 plus or minus 2i squared of 3 over 6. And then that reduces down to 6 over 6 is 1, plus or minus the 2 and the 6 reduced down to 1 over 3. So we have I squared of 3 over 3. So that would be the answer to this second question. Here's a quadratic equation that is not in standard form. You're going to have to subtract 12x from each side, and you're going to have to write it as 4x squared minus 12x plus 25 is equal to 0. Well, again, we have an a that's greater than 1, and these are not all divisible by 4. The 25 isn't. So I would say the quadratic formula is probably the best way to solve this particular question. So we have x equals opposite of b plus or minus the square root of 12 squared, that's 144, minus 4 times 25. Well, 4 times 25 is 100, and 100 times 4 is 400. All over 2a, 2 times 4 is 8. So 12 plus or minus the square root of, let me get my calculator out, 144 minus 400, what's that? Negative 256, all over 8. Well, the negative is going to come out and be called an I, and the square root of 256 is a beautiful thing, because you can see this 256 is a perfect square. It's 16 squared. So when you pull this out, take the square root of 256, you're going to call that 16i. Do you see there's no radical in here? Right, because we took the square root of 256 and just got a plain old 16. So now we're going to split this up into the a plus bi parts. So we have 12 over 8 plus or minus 16i over 8. Well, 12 over 8, 4 goes into each one of those. 4 goes into 12 3 times, 4 goes into 8 twice. And 16 over 8 is 2. So there's that one in a plus bi form. That's all caused by a negative discriminant. And then the last one is a word problem. In physics class, Tori discovers the behavior of electrical power, which is going to be called X. Electrical power is X in this one. In a particular circuit can be represented by f of x, that's function form. F of x equals x squared plus 2x plus 7. Now if f of x is equal to 0, solve the equation and express your answer in simplest a plus bi form. That means you're going to have b squared minus 4ac will be negative, because it's going to be a complex root. So what we're going to do is we're going to take f of x equals 0, and we're going to replace this f of x in here with a 0. So I'm just going to rewrite the original problem here. F of x is equal to x squared plus 2x plus 7. Now they're telling us that f of x is equal to 0, so we're going to replace this f of x with a 0, because that's what f of x is equal to, x squared plus 2x plus 7. Well, now we just have a plain old quadratic equation. And this, it looks like because a is 1 and b is an even number, I think I'm going to complete the square on this one to make it go a little bit faster. So I'm going to put the 0 over on this right-hand side, subtract 7 from each side, and get x squared plus 2x plus blank equals negative 7 plus blank. And in the blank, half of 2 is 1, and 1 squared is still 1. So you're going to add 1 to each side. You're going to factor this into x plus 1 times x plus 1. And negative 7 plus 1 is negative 6. You're going to take the square root of each side. So x plus 1 is equal to, this negative comes out and becomes an I, square root of 6. And then all you have to do is subtract 1 from each side, and you've solved this for x. X is equal to negative 1 plus or minus, I have to put a plus or minus on here, I times the square root of 6. And that's it for today.